We're given a surd, but it's in a fraction. So we need to rationalize the denominator. What does that even mean? We take whatever is in the denominator and multiply the numerator and the denominator by it. So if we multiply this by root 3 over root 3, you're then going to get root 3 over root 3 root 3. These two multiplied by each other is just 3. So that means our final solution is root 3 over 3. What if we have a slightly more complex problem? So we have 2 root 3 over root 8. We multiply the numerator and the denominator by root 8. So you're going to get root 8 over root 8. And so then that's going to become 2 root 3 root 8 over root 8 times root 8, as we know here, is just going to be 8. This root 8 can be simplified because you can take out whatever squared number is in here. So root 8 can be represented as 2 root 2. So that's then going to become 2 root 3, 2 root 2. Because if I do 2 squared, which is 4, times 2, it becomes root 8. So that's how you simplify it. It's not really a video about simplifying surds, but you probably should know how to do that if you're rationalizing the denominator anyway. So we know here that if you have, let's say, a root c times b root d, that's going to be the same as ab root cd. So 2 times 2, these are the numbers outside, is going to be 4. Root 3 times root 2 is 6 over 8. So we've just used this rule. And now we've got 4 root 6 over 8. 4 over 8 is obviously just a half. So that means our final solution is root 6 over 2. In papers, they never tend to give things that are as easy as the problems that I gave in the previous 2 examples. They tend to give stuff that looks like this. So where you're used to just multiplying the numerator and the denominator by this denominator, when you see a 2 plus root 7 or 3 minus root 6, whatever, you don't multiply the exact same on the top and bottom. You invert, flip the sign here and multiply it. So instead of doing 2 plus root 7, I'll multiply this as 2 minus root 7, 2 minus root 7. So now if I expand this, it's going to become root 3, 2 minus root 7. And remember your brackets. And then here, we're going to get 2 plus root 7, 2 minus root 7. So we can now expand the brackets down in the denominator. So we're going to get 2 times 2. So we're going to do first and last, inside, outside. I think it's called FOIL to remember it. So 4 minus 2 root 7 plus 2 root 7 minus root 7 root 7. So these cancel out. And then this would obviously just become 7. But let's also expand the top part. So we're going to get 2 root 3 minus root 3 minus root 7, which is going to be minus 21. So let's now clean this bottom part up. So you're going to get this root 7 times root 7 is just going to be 7. So you're going to now have 2 root 3 minus root 21, 4 minus 7, which is going to be minus 3. We can multiply everything by minus 1 to make it look a bit neater. And so you're going to get everything multiplied by minus 1. That would become positive. This would become negative. And this denominator would become positive as well. You could technically leave it like this, but I suppose just getting rid of this negative sign here makes it look a bit cleaner. I think both of these solutions are perfectly fine.